Hola, ¿cómo estás? Today we'll be doing the array manipulation problem. And it goes, well, it's probably, well, I guess we'll check. Let's go check the difficulty. Alright, well, that's not helpful. Alright, well, it's kind of weird, but I guess the way this has it sorted is that we're going to go through all arrays first. So, array manipulation, it is a hard problem with a 60% pass rate. I'm honestly pretty happy that I know that information. Alright, the problem goes, starting with a one-indexed array of zeros, already off to a bad start, and a list of operations. For each operation, add a value to each the array element. I'm going to assume does not supposed to be there. Add a value to each array element between two indices, inclusive. Once all operations have been performed, return the maximum value in the array. N equals 10. Queries are interpreted as follows. Add the values of k between the indices A and B. So 3 between 1 and 5 is going to get added. And that's shown here, it seems. But why? Oh, because these are individual arrays after each state change, huh? Because it's a one-indexed array. Why did they have to throw in that one-index BS, man? I don't fuck with that even remotely. The next one, it's going to be 7 between 4 and 8. So 1, 2, 3, 4, yep, all the way to 8. The largest value is 10 after all operations are performed. So what this sounds like to me is we're actually looking for, well, I was going to say that we're looking for where the most overlaps occur, but that's not the case because you could have two ranges that don't overlap at all. One could be like a 10 and one could be a whatever. Or you could have like one range where it doesn't overlap with anything, the value's 10, and then you have two others that are like 3 and 3 that overlap, and you would get 6, and 10 is greater than 6, and there's two overlaps, so that logic doesn't work. But I don't think it's a bad guideline to follow. I think generally you'll probably have some good luck with that. Alright, you know what? Let's try just working through a few examples. I know this says hard, but I honestly think this is much easier than a lot of shit that I've done so far. But then again, it's always a hidden complexity that hits you. It's always the complexity that you can't see right off the bat that really makes these problems difficult. In the very first query, we know that 1 to 5 is equal to 3, right? So the maximum becomes 3. And then the next thing is we take 4 to 8 and we add 7 to it. And there's some overlap with how that works. And so, oh, you know what? Another thing I think about this is that you're supposed to do this in a way where you can work linearly through the input. So you say like 4, I kind of want to make this into sets. I kind of want to make the starting indices into a set and the end indices into sets. And then I want to say that, well, I would have to make it into a dictionary. Okay, and that's like kind of memory intensive, but I think that would work. Alright, so if you make this into a dictionary, what you can say is that you can say for, I of n, where n is the amount of items in the array, you could say if the starting set has I, then you want to add the amount of value that is in the starting set, which would be 3 in this case. Since we're at index 1, you would say, okay, add 3, and then you're going to do that. Well, you're going to move on to the next index. Okay, so you're going to add 3 to the current element. And you're going to move on to the next index. And since we're going to keep track of a variable that lets us know how much to add to each index. But at this point, we're still at 3. So we add another 3, we do that again. Now we're at index 3, so we'd add another 3, index 4, add another 3. Actually, at index 4, we pick up 7 because 4 is in the set, or in the dictionary that we were talking about earlier. So we add 7, so now it's plus 10, right? Okay, so that was a way that, like, we could... I don't know if you would consider it brute force, but I do think that that was a method that would work, but over a larger amount of input. Because at that point, we're iterating over all possible elements in the array. But if you just look at this, it's not hard to tell that, okay, the maximum value you're going to have is a 10, and that's going to be because of, you know, you have a 1 that adds 3, and then you get to index 4 and it adds 7, and then at that point you have 10. I wonder what this looks like. I'm going to make a number line. Actually, I'm going to go ghost for a minute. I'm not going to say shit because then I have to go back and edit it and it's like a bitch. So I'm going to shut up.
Oi, oi, oi. Welcome back. So, here's what I'm thinking. So, I'm not exactly sure what the best way to approach this is, but what I would like to do is I would like to flatten the elements in queries. You know what? I got this shit like as a small little window. I would like to flatten the shit that's in queries, and I would like to put it into, I would like to put it onto, well, like in an array, right? And I want to sort the arrays, or maybe put it into like a dictionary that I'm able to map somehow. And I want to basically be able to say, okay, at index 1, or, okay. What I would do is I would put into an array, and I would literally just sort by whichever value comes first, and I would say 3 comes first, right? Because if you look over here, you know, we have queries at index 1, we add 3, right? And then the next thing is at index 4, that would be the next point that we hit, we add 7. And then at index 5, we subtract 3. And I would basically like to encode it this way so that you're able to do that. But there is a caveat, and that's that we basically have to iterate over all elements in this array, which is like, what, n squared already? Oh, you guys don't even, hold on. Make this just a little smaller. We have to iterate over all the elements in queries, which is already like an n squared solution, and then we would have to sort them, which is like an n log of n solution. So you're off to a pretty bad start that way. I mean, that's a solution. I definitely can't say that it's the best one, though. I will say this shit does seem to be like pretty much in order already, though. I don't know how much of this is like... I'm going to run a test and see if it'll tell me anything about how the actual input is being formatted, because if it's the way that it's suggesting, then this is already pretty much in a sorted order for us. It goes 1, 4, 6, 5, 8, 9, so that's already sorted. But you definitely can't trust the input in the way that it gives it to you. Oh my god, whatever. Oh, cool. Oh! No. Okay, so it's not exactly perfectly sorted for us. 1, 4, 6, 5, 8, 9. A lot of the times it is, though. Yeah, but I mean, any amount of it not being sorted is an issue. I wonder if I do something with, like, pairing shit up, if that'll work. Because this is 2 to 6 and 3 to 5. You could say that if the next index is less than the first end index, that you can add the two together, and that would give you 15. And then you can also say, there's kind of like a thing of like, how many indices can like be affected, basically. I guess in theory you could pretty much infinitely stack overlapping indices on each other.
But I wonder if there's like a good way of modeling which indices are like intertwined, like correlated with each other, or like affecting each other. Because if we could just like check, like, okay, do these two, you know, what is 1 plus what is 7 plus 1 here? Because these are overlapping. That would be easy. And if you could just do that for every pair, then that would be easy. But that's the thing, is that the indices overlap. But if you could find a good way to model, you know, which indices are overlapping at what points, then you could easily just say, okay, well, these indices are overlapping, so we take 8, 7, and 1. But then again, if you're doing that for all of it, then it's like going to be like an n squared solution where you're going back and, you know, iterating over all of the input again. But it's at least like, what, 1/3 the input space, since it's one number out of 3 instead of all 3. This question really isn't bad. There's just a lot of different directions that you could theoretically take this. Man, I want to ask ChatGPT what the input or what the time complexity is on this, but I feel like this question's easy enough to the point that I would be cheating. Well, see, I think the closest thing I got to modeling which indices are affecting each other is probably when I flattened out the queries into an array. So, you know, I could do something that would actually probably help me not have to sort this after iterating through the data. I could probably just take what it gives me for n, initialize an array of zeros, and then literally just look at each index and then add it to its place. Okay, I think I see how I'm going to do this. God, I just shut up because I didn't feel like explaining this. I have a habit of not wanting to explain things because it's too much effort for me. So here's what I'm thinking. This problem wants us to find the maximum value in the resultant array, right? And to find the maximum value, you basically just have to find... you look at the points where shit overlaps. Well, I guess that's not even technically true. There's like an accumulating effect, right? Where these indices are overlapping, there's an accumulating effect. So for here you have 1 and 5, you know, through these indices you have 3, right? And so you can say is that, okay, at index 1 I pick up a 3, at index 5 I throw it away. And you could also say that since 4 in the second query is less than the end of this, they're overlapping, right? And so you could say at 1 I pick up a 3, and then at 4 I pick up a 7, and then at 5 I drop a 3, okay? And that's just a very efficient way to basically figure out what the maximum values are. And then the next thing is that you might say, okay, well that's terrific. We're able to essentially, you know, find the solution. But the one thing about it is that you have to make sure you're finding these in order, because if you found, you know, the +3, and then if you didn't put this shit in order and you just said, okay, I'm going to add 3, and then I'm going to subtract 3, and then I'm going to, you know, go here, I'm going to add 7, I'm going to subtract 7, then that's not going to help anybody. So you have to do this shit in order. And so you're going to start off with a 3, and then you're going to add a 7, but that also assumes that you've basically looked over this input in some way, have it in order. And normally, in order means that you're going to have to sort something, but there is a workaround for this, and that is to iterate over all of the input, put it into an array of empty zeros, basically, and then just do something like, look at this, you say, okay, my first element is a 1, we're going to say you add 3 at that point. The second one is a subtraction element, so you say at 5 we subtract 3. And then you're able to put that onto a number line, well, into an array, and then when you iterate over that array, you'll literally just be iterating in the exact order you need to. So hopefully that made a little bit of sense. I feel like I wish I was better at explaining things. I don't know how else to put this. It's imperative that I'm able to explain things clearly, because That's going to be a large part of what I'm interviewed over, and that's a large part of why I made these videos, is because I was already talking to myself, trying to get better at explaining things, and I was like, well, if I'm sitting here solving problems and talking to myself, then I might as well just screen record and put up a phone to record my voice and just post this shit. Alright, or n log of k or some shit, who knows, man. So, what we're going to say is we're going to go ahead and print the input, because it's just what good programmers do. Alright, so what's the first thing we do? Well, the first thing we do is we're going to iterate. You know what? The good thing is we might be able to avoid an n squared solution. I think we might be able to just do an n solution. So we're going to say for query and query. I'm seriously going to have to do something about my typing, because this is actually ridiculous. It's embarrassing watching the videos and look down on my keyboard. So if query, you know what, I forgot. We need to initialize the array of zeros. So we're going to call it flattened. And we're going to say for probably blank in range, for underscore in range. And for those of you who don't know, that the underscore basically means that we don't actually care about the index. We just want to do something a number of times. Because the underscore basically means we have no index. In range n. 0 for blank in range x. So query at 0, query at 0 equals flattened. It's actually kind of funny, because the one indexing of the array I don't actually even think matters. Query at 0 flatten that. No, wrong. Flattened at query 0 is equal to query at 2. And then basically same exact thing. Query at 1 is equal to negative query at 2. Okay, cool. And that is honestly that right there. And then what we can say at the bottom is that we can iterate again. So this becomes n plus k or something. That's probably what this is an n plus k solution. Element in array, now flattened. We're going to say value is equal to 0. Value plus equals element max value is equal to 0 off the ripski. We're going to say, what is this? Why is the spacing all weird? Max value is equal to, dude, max value and value. And we are going to return that bad Larry. Alright, let's run it. I got a runtime error, out of range. Are you telling me that flattened? Maybe it's because this isn't inclusive? No, it is because of the one indexed BS. I just have to basically subtract 1 from this. I think. Should be. Wrong answers regardless. How shitty is that? Well, let's see what the flattened array was. Oh, you know what? I'm actually kind of curious. I might have solved it. Okay, it didn't, but I think that was a step in the right direction. Oh, you know what? It actually solved one, but messed up another. Interesting. Alright, let's try this. So, flatten becomes 18708. Let me just throw this into an array really fast. Let me break out the notebook. Alright, well this is actually a little bit concerning, because now I'm starting to think there might have been something that I didn't see. Because I just followed the exact same procedure on my... Alright, well I figured out where the issue lies. It's kind of a weird thing how they're doing this. I don't really appreciate it, honestly. Alright guys, let me show you where I'm at with things. So, if you guys are looking at... Well, you know what? Look at the screen really quick. So, this is the array that my program is currently outputting. It says that we should, at the very first index, add a 1, add an 8, add a 7, add a 0, add another 8, okay? Try to keep mind of these 5 numbers, okay? If you come here, right, and you, like, put together what array would form, at the first element, we're going to add a 1, okay? So then... the first element in our array would be a 1. Next, we're going to add an 8. So 1 plus 8 is 9. Next, we're going to add a 7. 1 plus 8 plus 7 is 16. Okay, and the next one we're going to add a 0, and it's going to give us 16. But the next one needs to be 31, and this is where it gets tricky. Because, keep in mind, this is index 5 where we build 31, right? So, what operations are occurring at 5? Well, based on the queries... You guys might not... Oh my god, focus! Based on the queries, at index 5, we add a 15. Like, we add a 15, but we also subtract a 7. And so if you do 15 minus 7, you get 8. And if you try to add 8 to 16, you get 24. Now, the thing is that there's two things here. 31 is actually the highest expected value, right? And so there's two things that you can notice. So I said that, you know, at index 5, we both add 15 and subtract 7 as per what it says in the things. And you'll notice that 24 is exactly 7 off of 31. So if we just never subtract the 7, we get the right answer. But you could also look at the actual operations we'd follow. So this is like the operations in the query performed in order. So first, we're going through index 2 to 6, and we're adding 8. So that's exactly what this is. The next thing we do is we go to 3 to 5, and we add 7. The next thing we do is we go 1 to 8, and we add 1. And the last thing we do is 5 to 9, and we add 15. And you can see that reflected in all of these. Now, the thing is here we have 3 to 5 plus 7, okay? I'm just going to make this one big input, okay? And then down here, we have 5 to 19. 5 to 9. We add 15, okay? And when you do it here, you can clearly see, okay, 31 is there. And I think I think the only reason that's occurring is because this maybe should be happening slightly later. But I'm worried that if I do that, it's going to go out of range. Yeah, it's out of range. Okay, but let me see if I can fix this. I think we're actually onto something here. I think we can work from this. So if flattened, and we want to take the length of this, if the length of flattened is greater than query of 1, else pass. Can I just pass? I didn't do something right. Oh, so I would just say that it's itself. Alright, well, I could have expanded it, but I was trying to get all fancy with the ternary operator, but we'll just try this. Okay, I think that was all that was wrong with it. Wow, not bad. Really not bad. Like, off screen, I didn't have a lot of misses either. Like, I worked through a lot. Well, actually, I only worked through a single page of math. I was pretty on point with the direction that I went with this, for sure. And the craziest thing about this is it said that it was a hard problem for an intermediate level problem solving. I've done an easy problem for an intermediate level problem solving, and with that said, we should probably just go take a look at this and see what we learned. Honestly, I don't think I learned anything. Nope, I didn't learn anything. I feel terrible for not learning anything, but it's like working out a muscle, man. Just because just because you don't PR doesn't mean you're not setting yourself up to PR later. And I suppose if this was a lift, I probably would have PR'd. I mean, I did this very quickly. I know for a fact I couldn't have done this as quickly as I did if I was back in the day trying this. All right. Anyhow, hope you guys had a nice day. Hope you guys enjoyed the video. Peace.